Hello. We're going to do an exercise. The exercise is about using machine learning, and in this case, an artificial neural network that we're going to use to predict the churn of a list of customers. This scenario, we have a list of customers from a telco company in which we can have, for example, understand each customer might have purchased some package of internet plus phone number plus movie services and series. And then we have in this data features like how much they're paying per month, do they have high-speed Wi-Fi, optic fiber, did they pay by card, did they pay by Visa, MasterCard, or different brands, if their gender, other males, other females. Maybe we can have also in one of those columns their age, their region. So we're going to use this set of customers of records, about 10,000 records, and we're going to predict which is the churn for these sets of records. We have to consider that making churn is when you are having a relationship with one company, but sometimes you decide to just close your contract and don't renew again, don't purchase anything again. So that's what we're going to produce. Of course, in our data set, we have the historical data. So that's what we're going to use for our purposes. So we're going to use Azure Machine Learning. When you open Azure Machine Learning, first things we're going to do is read from the data lake the file which contains our 20,000 records from our customers. We're going to load them into data frame. Then we're going to call Keras and TensorFlow. TensorFlow, it's the architecture that leverages the Spark nodes that we have deployed for our Azure Machine Learning. And Keras, it's the library which we're going to use to call the functions. It's going to enable us to create the objects for our artificial neural network. We're going to start by defining layers, one output layer. So we'll define a sequential object, which is going to enable to pass information sequentially from one layer and one neuron to the other. And we're going to create some number of neurons for the activation function, which would be ReLU, which enables to create patterns, create vectors based on the input records that we're going to first transform by hot encoding and normalizing. And then we'll use sigmoid function, which is very useful for our classification problem in order to determine which of the patterns, which of the records may include for one pattern or the other. Besides that, we will use Adam Optimizer, which is the software that can manages all this gradient descent activation function from sigmoid. And we use cross entropy, binary cross entropy function, which is the one that enables to manage the gradient descent calculations that we will work on the different multidimensional, high dimensional spaces that are going to be created by our neural network.
Yes! So, first things first. As you see, we've started a notebook, which of course here I have already created it, but I will show you step by step how it looks like. I'm using the serverless Spark Compute, but you can create a specific process to compute with your nodes. You can use the free account by Microsoft, by the way. And in this case, I'm using PySpark because it's the serverless Spark Compute that's included in the Azure Machine Learning subscription I have. So you will see there are small details between PySpark or Python 3.8 or Python 3.10. First thing that we see is that I'm using pandas library from Python to read the telco file that I just showed you in some minutes ago. And we are very easily create a data frame that's including all those 16 features, 16 columns that we have seen in previous video. First thing we're going to do is just transform the churn column to change a yes by a 1 and a no by a 0. So we're getting it categorical feature into numbers. This is our target classification variable. Then we're going to remove the empty values for the total charges, as we really want to have only positive values for total charges feature for our customers. And what we're going to then see is for our numerical columns, our numerical features, we have to investigate how the range of values is distributed. Why? Because this is going to impact on the neural network. Neural networks do not like to have, for example, a minimum of 1 and then a maximum of 72 or a minimum of 18 and a maximum of 8,000. It helps for the neural network to create high-dimensional new spaces, to have the data normalized. And what are we going to do? We're going to use normalization by calculating the log value of the monthly charges, and then we're going to divide the mean by the standard deviation, and we're going to subtract to the value the mean and the standard deviation. So we're going to have normalized around 0 as the mean, all values. So they will have minus small values and plus small values, but their mean will be 0 for all of them. That's something with decimals that our neural network really likes. Another important point is to see how all those features are described. It means those are categorical values. The categorical values can have several values for each. For example, gender, in this scenario, we only have 2, men and women. All right. But for example, if we go to any other, like could be payment method, we have 4 different payment methods. So a data scientist, what we like to do is to analyze the distribution of our data sample for those categorical features or attributes. So for example, if we analyze how the gender, male and women, are distributed in our data set, we see that more or less it's a quite fair distribution, because of course this might impact on the prediction of churn. And as we don't want to have bias in our data set, we analyze for each of those which are the distribution, which is the distribution for networks. All right, then what we're going to do is that we're going to transpose and calculate all those numerical values, and we're going to create a 0, a 1, if they do have each of the values for each of the categories or features, which means we're creating kind of vectors. As you might see, this is called we are calling a function called dummy, which is going to transform each of the text values into a 1, 0, and creating an additional column per each of the possible options. So as you'll see, we have, for example, payment method bank transfer, payment method credit card, payment method electronic check, payment method mail check, and for others like how long have they been as customers with us. Everything is transformed in different tabular columns, which will help the ReLU function to create vectors. Well, now that we have our data prepared, it's a right moment to install TensorFlow and install Keras. That's awesome that we have those libraries available to work with the neural networks. As you know, TensorFlow is the software that enables to use the Spark compute optimized for neural networks, and Keras is the API that is going to help us call the different objects and methods that we're going to utilize for this scenario. Then, once we have installed our libraries, we're going to create a sequential object, and we're going to also create the dense layers and the output layer. In this scenario, we have first the input layer. The input layer is going to read each of those columns that we have described as features that can predict the churn or not churn from our data set. Then we have the ReLU also activation function, which is going to read all those patterns between the values of those records. And it's going to represent a new space, a non-linear space, in which it's going to plot all of these customers. But for us, it's going to be very difficult to do because we don't have nor 2 nor 3 dimensions, but to 16 or more dimensions for each of those categorical values. So that's what this dense layer is doing in the activation function. And then finally, the final dense layer, the output layer of our neural network, it's going to use the sigmoid function, which is going to compare those patterns, and it's going to compare the final label, churn, yes or no, and it's going to calculate the probability of that pattern to be classified as churn or not based on our data set. So once we have defined how our neural network is going to work, we can also call how are we going to compile and train our machine learning neural network. We're going to use a loss function called binary cross entropy, because we only have 2 classes to classify, so we can use binary. This function is going to enable, for this multi-dimensional, high-dimensional space that our hidden neural network layer is creating, it's going to enable the gradients to be smoothly calculated overall all those data sets, trying to find the hyperplane that can describe the 2 classes. And the optimizer Adam, it's a famous optimizer that combines 2 techniques to enable those gradient calculations, those error mitigations, to minimize the error on those probability assignments. And also is going to enable the back propagation of the information. Each time there is a training epoch, it's called. An epoch, it's when the data flows from the input into the hidden layers of the neural network. Once the result is done, and based on the weights that the neural network might have calculated, Adam is going to backpropagate several times, each of those times trying to define this hyperplane that is going to adjust the prediction for churn as good as possible for all the data that is being inputted as training data sample. The metrics, of course, accuracy. Accuracy, it's a great metric because it's going to represent how many finally True positive, have we predicted? So true churns, have we predicted overall the predictions that we've done? So this is really important ratio, as we want basically to have as good accuracy to know these values. What we're doing later on, what we're doing is separating with the train test split object our data set. As usual, we like to divide 30% is going to be test samples, and 70% is going to be used to train our neural network. Then we're running the neural network, we build it, we compile it. As you see, we're going to train it with model fit. Finally, I'm using ReLU, I'm using sigmoid, Adam, binary cross entropy. I'm using those two data sets we have done. And let's see how the epochs are already shown, and the accuracy and the loss function values appears for each of the epochs. The process is going to do another epoch each time it sees that with backpropagation it can adapt the weights even more to further build that multi-dimensional nonlinear space that is going to represent the two classes that we're looking for. Once we have this, we can see the metrics, and as you can see, the metrics are quite good. 0.8 accuracy, 0.7 for outsample accuracy. That means records from the training have a bit higher accuracy, but the sample that has been used for test, which is not been used to train the model, is also great accuracy. Predictions very good, recall too. That means it's the model is predicting quite good the churn. Keep in mind those values, and also we have here the aura area under the curve, because we will analyze it in a moment with more details. But first, I would like to give you a quick introduction to all those metrics, for you to understand what's a confusion matrix, what they represent. Keep in mind what are true positive, true negatives, false positives, and false negatives for a scenario like this.